All right, guys, in this exercise, we are asked to find the vertex and the x-intercept to this quadratic equation right over here using a method called completing the square. Let me just read the quadratic to you. It's a parabola y equals negative 2x squared minus 8x plus 2. So we're going to proceed and complete the square in order to find that vertex. Now it's going to be put from standard form, which is what it's in now, that's standard form, and we're going to transform it into vertex form, which is written across here. So vertex form is when y now equals a bracket x plus h all squared plus k, where h and k are the coordinates of the vertex for the parabola. Now the vertex of a parabola is the highest or lowest point on a parabola, the maximum or the minimum. So let's go through and start to complete the square on this one here. But before we do that, we might be able to factor it. So I'm going to attempt to factor it here. So we've got y equals, and take negative 2 out as a factor. There's a negative 2. So that means we've got x squared, and then a negative and a negative will make it a positive, plus 4x. Let me try that. Negative 2 times positive 4x is negative 8. That works. And finally, we have the 2 here. So then we're going to have a negative 1 right over there. Negative 2 times negative 1 gives us positive 2. Okay, now we're going to set it up so we can complete the square. So now we'll have y equals negative 2. And we're going to put brackets here. X squared plus 4x. And take that negative 1 and drag it out over here. Like that. We're going to leave this little space over here because it makes it easy for us to complete the square now. All right, here's the process. The process is we take this middle term here of the trinomial, the middle one. It's a 4x. What we're going to do is take that 4 and divide it by 2 and then square it. So what is that going to turn into? Well, 4 divided by 2 is 2, so 2 squared is what we're going for, 2 squared. And what's 2 squared? Well, we had 4. Now, because we've added 4, we need to take away 4. So it's balanced. So we take away 4. Now we've got a perfect binomial right over here, right there. So we're going to change into the binomial form here, the perfect square. So what part are we going to change? Let me put brackets around that. This part here and that part there. Perfect square right there. So the square will be now y equals negative 2, let's put a square bracket here, and this part here in black becomes, these two brackets here, x plus 2 all squared. Why x plus 2? Because it's that 2 right over there, because that's what we're squaring. That 2 right there, that turns into a 4 right there. If we write that out twice and expand it, we'll end up getting all of that. So we also have a minus 4 and a minus 1. See that? So we can just add it on the end. So minus 4 minus 1 adds up to minus 5. That's a minus 5 right there. And close the square brackets. So now we've completed the square, but we need to improve a little bit this so we can get it into the vertex form. And that means I'm going to expand the minus 2 with a minus 5 there. So let's just go ahead and expand it so it looks more like that equation there. Negative 2 bracket x plus 2 all squared. There's that binomial. Negative 2 times negative 5, if we expand, becomes a positive, plus 10. Now that is in vertex form. So we have transformed the above equation here, the quadratic equation here, from standard form into vertex form. And that's vertex form right down over there. So now we can extract the actual vertex. In other words, the highest or lowest point on this parabola. So what is it? Right, there's our h and there's our k. So that means our vertex is the points right there. See that plus 2? That becomes a negative 2 point, comma, and positive 10. So there's our point, negative 2, 10. Now that we've got the vertex, the next part we need to deduce is to come up and find the what? We need to find from this where it cuts the x-intercepts. So that means we're going to take this equation here, vertex form, and make it equal 0. Why? Well, when y equals 0, that gives us where it cuts the x-intercepts. They're going to give us the zeros for the x. So let's make this equal 0. So I'm going to take that y and replace it with 0 right there, see that? And write it up there. So 0 will equal this now. So 0 equals negative 2 bracket x plus 2 that's the binomial, all squared plus 10. Okay, since we got our 0 there, let's take this part and bring it over to the left and change it into a positive. So let's do that. So bringing it over, it means it becomes a plus 2. So it's 2 bracket x plus 2 all squared equals, it's still positive 10 because the 10 stays on the right-hand side of the equals. So what did we do? We took this part here, brought it over, made it positive. So there we got that now. Let's divide both sides by 2 to get rid of that 2 there. So divide by 2, divide by 2. So we're left with, on the left-hand side, x plus 2 all squared, and that equals 10 divided by 2, 5. So all we have to do now is square root both sides. So let's do that. Let's square root that, square root that. So we're left here with x plus 2 equaling plus or minus the square root of 5. Let's take that positive 2 and bring it over to that side of the equals. It will turn into a negative. So that means x is equal to negative 2 plus or minus the square root of 5. So that's going to give us the 2 points because it's plus or minus. So we're going to have 2 points cutting the x-axis. They're going to be the 2 roots or the 2 zeros as they call them. So let's separate them. So on the left-hand side, we're going to have negative 2 minus the square root of 5, and negative 2 over here plus the square root of 5. There are the 2 points. Now what's interesting to note is that when you look at this in standard form up here, the a component, or the coefficient of x squared, is a negative number. It's negative 2, meaning that this parabola is going to be concave down. So we're going to have a maximum point. The highest point is this vertex here, negative 210. So if we were to draw this, negative 210, it would be, let's have a look here. Let's say this is negative 2 here, and 10 would be, let's say, up here, 10. So there's a lot of writing here, but you can imagine negative 210 will be somewhere up over here, approximately right there. That would be our vertex right there. So let me just put that point there. Let me put another point there. There's our vertex right there. So it's going to go a parabola down here and down through there. So if I was to put a dotted parabola, it would look through all this messy writing, come down there, and then down through there. Now, where would this cut the y-axis? That's when x equals 0. So imagine substituting x equals 0 there. That would turn into 0. Substitute x equals 0 there. Minus 8 times 0 is 0. So all we're left with is 2. So y will equal 2. So that'll cut a 2 right over here. So that's what the parabola would look like. Now, that's very rough. I'll be right back with a perfect parabola drawn right over here for you to see it a lot more clearly. So just summing up, we have completed the square on this standard form, and we've created our vertex form here. That's the parabola in vertex form. The vertex is negative 2 and 10, and the 2 x-intercepts is negative 2 minus the square root of 5 and negative 2 plus the square root of 5, cutting that x-axis, and it's concave down. So I'm about to do the sketch for you. I'll be right back. All right, guys, here's the sketch of that parabola. As you can see, it's concave down. We have again the vertex, negative 210, which we calculated earlier, negative 210, and we used completing the square. Now the 2 x-intercepts again is negative 2 minus the square root of 5 right there on that x-axis, and negative 2 plus the square root of 5 right up over there. There you have it, guys.